Okay, hi. So what I want to do here is just show that this is true, that a one standard deviation increase in a predictor in the standardized model leads to a one standard deviation increase in the response. So we have again, so let's just do it for p minus 1 equals 2. So I have y star equals b1 star x1 star plus b2 star x2 star, and this is our standardized regression function. Okay, and now suppose we increase x1 by s1. So we make a one standard deviation. So the notation for these kind of things is like this. You just say you want to increase x1 by s1. Now, when I increase x1, s1 is a constant now. It's based on the original data. I'm not saying this will change S1 or anything. I'm just saying I'm looking along the function. This is all based on the data. S1's based on the data. And now I'm looking at this fit. And I'm making a change in X1 of one standard deviation. Of course, these are the original variables, right? No star here. And I'm increasing the first predictor by S1. Well, let's see what happens to Y. What the hell? To y. Yeah. So what happens? So when x1 increases by one standard deviation, what happens to y? How much does y increase by? Anybody? Y should increase by b1 star times sy, right? This tells me what happens over here. But the key is that the units are sy now. Okay, so let's see that. So I want to see that y star. So we hope to see. So let x1 go to this and check that y goes to y plus b1 star sy. Okay. All right, well, let's begin before we run out of time. So we have y star goes to, if x1 goes to that, then y1 star goes to b1 star, right? And here I had x1 star, so I'm going to write that in the original variable. But I'm going to add s1 to x1. So this is x1 plus s1 minus x1 bar over s1, 1 over square root n minus 1, and we'll just write this the same way here. This is just coming along for the ride, as they say. Okay? So if x1 increases by s1, this is what happens to y star. Of course, if x1 increases by s1, y star is going to change, x star is going to change, y star is going to change, and y is going to change, okay? All right, so we do that. Now, what can I do here? I can group this. So this is not supposed to be hard. So this is equal to b1 star, and I can group this a different way, right? So I can write this now as x1 minus x1 bar over s1. And here I just have s1 times s1, which is 1. So the whole thing becomes b1 star, right, times, this just becomes x1 minus x1 bar over s1 plus 1 over square root n minus 1 plus b2 star x2 star. Don't need much explanation for this next part, so we just get b1 star x1 star plus b1 star over square root n minus 1 plus b2 star x2 star. Okay? Yep. Okay. But what is b1 star x1 star plus b2 star x2 star? That's good old y star, right? So this is just y star plus b1 star over square root n minus 1. Did I just say good old y? Okay, so that's y star plus that, right? Okay, now let's write y star out. Y star is y minus y bar over sy, 1 over square root n minus 1, and plus b star square root n minus 1. Common denominator, sy over square root n minus sy times square root of n minus 1. So I need to multiply both by sy here. So we get y minus y bar over sy n minus 1. And now plus b1 star sy. Okay, so we're done basically. This is equal to y plus b1 star times 1 standard deviation minus y bar over sy time 1 over square root n minus 1. So y went to y plus b1 star sy. Okay, maybe it's more detailed than you want. All I really worried about is that you believe it and understand it. So, all right. So I'm going to have a next video. I think is going to be a demo from the screen, and then we will have a couple multicollinearity videos. We did this very carefully, so it shouldn't be as many for the last chapter as there were for this chapter, but that's what's coming up. Okay, thank you. Have a good night and stay safe.